We'll have a look at example 3 now. Example 3 gives us the normal grain information, stowage factor, initial displacement, kg, how we're going to load the vessel. In this particular one, it's asked us to use the KN tables to determine whether the vessel complies with the stability requirements of the grain rules. So let's have a quick look at stability requirements. GM 0.3 or more, heel due to grain shift 12 degrees or deck edge immersion, residual area has to be 0.075. So in this particular problem, obviously we have to draw a GZ curve. So as in the previous problem, look up the volumes for the holes, divide by the stowage factor to get the weight, multiply by the kg to get the moments, divide the moments by the weight to get our final kg. Volumetric healing moments looked up in the table, get a total of 6,890. We'll have a look at how we use these healing moments shortly to do with the healing arm curve. But let's just move to the graph itself. You should have done this before with Simpson's rules, and we simply write down the angle of heels 12, 20, 30, 40, 50, 60, 75, go into the KN tables, look it up at our displacement of 15,504, write down the values of Kn. Kg sine theta, well, our final Kg was 6.93, so 6.93 times sine 12, 6.93 times sine 20, etc, etc. Then subtract one from the other, there are GZ values. What we then do is plot our GZ curve. So I've put 10, 20, 30, 40, 50, 60, 75, picked off all the values of the GZ, and I've drawn the GZ curve. Okay, so I've just drawn the GZ curve. So what do we need to find out? Well, first of all, GM. Well, from the tables, your hydrostatic particulars with your final displacement, look up the KM, subtract that from the our final kg of 6.93, and if our GM is 0.3 or more, then we're fine, and from the tables you'll see that it's 1.4 meters. You would do that initially. That will help you actually to draw the curve, because if you know that your GM is 1.4, you could actually plot that position at 57.3 degrees, draw your straight line, because the curve is a tangent to that that line that you've drawn. So there's the tangent that we've drawn, and so we can start our curve off on that. So we know our GM is 1.4, 57.3, we can start the curve off quite comfortably. Now we need to know the angle of heel due to grain shift and the residual area. To find this angle of heel, we need our healing arm curve, or if you like, this straight line that we've drawn, and we use the formula. It's the lambda formula, which is here. So lambda at 0 is our assumed volumetric healing moments over stowage factor times displacement. This is where our healing moments come in now. So we get 6,890, and we divide that by stowage factor times our displacement. Of course, it's the final displacement, and we get 0.3. Then we have to use the second part of the formula, so the lambda 40 degrees, is 0.8 times the 0 value. So it's 0.8 times 0.3, 0.24. So we plot 0.3 at 0 and at 40, 0.24. And we simply draw straight a line, and that's a healing arm curve it's called, but it's a straight line. Where it intersects the GZ curve, that is the angle of the grain shift, angle due to grain shift. And we find from the curve it's more or less 12 degrees. So we're right on the cusp there really, because the maximum is 12 degrees. So looking at the curve, we're more or less on it. We're possibly just okay. What we then have to do is work out the area under the curve. So we're going to use the Simpson's multipliers of 141, because we've just got three values. We could do more if we wanted, we could work out more, but 0 degrees. Now let's find out whether it's 40 degrees that we go to. Well, when we drew the curve and we drew our line up against the curve, we found that the value there is 43 degrees, so we've got to use 40 degrees. We also went into the deck edge table and looked up with our final displacement and found that that exceeded 40 degrees as well. So this particular table went in with the displacement and found that it occurred at more than 40 degrees. So we use the 40 degree value. So we go to the curve at 40 and draw a line straight up. Where it cuts our healing arm curve there, go across and measure the value. Well, we know it's 0.24 because we worked it out mathematically. Then go to the top, draw the line straight up at 40 and go across and see what value you get there. Obviously it's 1.21 because we got that value 40 degrees 1.21 and lambda at 0 so at 40 degrees was 0.24. So we get the difference between them, between 0.24 and 0.41, sorry, 0.24 and 1.21, and we find that's 90.97. Because we're going from 12 degrees, we have to get the midpoint between them. Between 12 and 40 is 28 degrees, half of that is 14, so 12 plus 14 is 26. Go to the curve at 26 degrees, draw a line straight up. Go across and measure the value on the GZ at 26 and then measure it at the top of the curve there. And we find that the bottom value was 0.25, top value was 0.85, so the difference between them is 0.6. So that's where we get the 0.6 value and the 0.97. So as far as Simpson's multipliers go, it's 0, 0.6, 0.97. So if we look at our multipliers here, 0, 0.697, 141, multiply through, and then we use Simpson's first rule, 1/3, and the common interval is 14 degrees now. It's not 10 that you're used to using for the GZ curve, it's 14 because we're going from 12 to 26 to 40, and between these values here is 14 degrees. So it's 14 over 57.3 times our area, 0.274. Residual area minimum 0.075, so the vessel does comply. So just to quickly recap, draw up the curve, use your lambda formula to get the value at 0 and at 40 degrees and draw your straight line. Once you've worked out whether it's going to be 40 degrees or less than 40 depending on the three values, well the two values, the curve itself, the value from the tables, the angle of heel data, and also the 40 degrees value. So the most you can go up to is 40 degrees. If any of those two values we've just mentioned are less than 40, then you have to come back. And of course that will affect 0 to whatever value it is, will affect the mid-range value that you're going to use. Once we've drawn the line, where it intersects the curve, that's our grain heel. Okay, the heel due to the grain shift. And that has to be 12 degrees or less. So if that, once we'd drawn that, if it had been more than 12 degrees, this vessel wouldn't comply with the regulations. Use Simpson's rules to calculate this area under the curve, and as long as it's more than 0.075, we'll be fine. And that's how you would solve that problem, using the KN tables, drawing the curve, and then using the lambda formulas to draw the healing arm curve.